Welcome back to NCERT Class 9, Chapter number 10, Gravitation. Children, in our previous classes, we completed a major part of this chapter. What is that? Theory discussion we have did. So, dear children, in today's class, one more, it's called as a very important part, we can say, because it consists of all numericals which comes under gravitation we are going to discuss. So, in that is exercise part today I am going to discuss, children. The first question, that is page number 143. The third question, children. What is the magnitude of the gravitational force between the earth and a 1 kg object on its surface? Mass of the earth is 6 into 10 to the power of 24 kg and the radius of the earth is 6.4 into 10 to the power of 6 meter. Clearly they has given that mass of two objects here given. One is mass of the earth, the other one is what? Mass of the object, and also radius they has given. They asked us to calculate what is the magnitude of the gravitational force. Nothing but a force we need to calculate, children. So in order to solve this problem, we have to use universal law of a gravitational formula, children. It is also called as a Newton's formula, isn't it? Or gravitational force formula, we can say. So what are the things, children? That is our solution you can write. That is mass of earth. What is the mass of the earth, children? 6 into 10 to the power of 24 kg. Similarly, mass of what? Object. How much? 1 kg. So, what is the radius? The radius is 6.4 into 10 to the power of 6 meter. Isn't it, children? And the gravitational constant value we know already, isn't it? 6.7 into 10 to the power of minus 11 Newton meter square per kg square. So what is the force they has asked? Force is what now? Question mark. So what is the formula? Using formula F is equals to G into mass of earth, then mass of object. ME means mass of earth, MO means mass of object divided by radius square. This is the what? Formula. Now we have to substitute all the values, children. Substitute the given data in this formula. So what is that? F is equals to, what is the Z value? 6.7 into 10 to the power of minus 11. Mass of earth, 6 into 10 to the power of 24. Mass of the object. No need of a conversion, children. Directly they has given in kg. So take it directly kg only. Divided by R square, nothing but a radius square. 6.4 into 10 to the power of 6 whole square. Is it correct, children? Okay. Now, this can be equals to, let us take, children, all exponents one side. 6.7 into, what is left? 6 into 10 to the power of 24 minus 1. Isn't it, children? Yes. 24 minus 11 whole divided by, into 1 means 6 only. No, anything multiplied by 1 means the same value you will get. So, write it directly. Then 6.4 into 6.4, because it is a whole square, no, we can write it 2 times, into 10 to the power of 6 into 2 means 6 2s are 12. So what is that? 10 to the power of 12. So this is what equal to now 6.7 into 6 divided by 6.4 into 6.4, which is what? 24 minus 11 means 13. Then 13 minus this 12 goes to numerator means minus. So what is that? 10 to the power of 13 minus 12. Got it, children? Okay. Now, what is that? 6.7 can be written as 67 divided by 10 into 6. Then 10 to the power of 13 minus 12 means 10 left, means nothing but a 10 to the power of 1. This is 10, children. Then 6.4, nothing but a 64 into 64 into 100. Nothing but a here 10 will be in the denominator. If it goes to numerator means it will become 100. So now do cancellation, children. It will become easy. 10 get cancelled. Then 2 3s and 2s. Okay. Then 1s, 6s, 5s, 0. Isn't it? Then once again, what is that? Yes, 2 8s, 2 2s, and then 5s. Okay. Then now multiply, children. That is rough work you can do here, or else still it will goes. I think no. Okay, we'll multiply 67 into 3 into 25 whole divided by 64 into 8. Okay. Now what is this? That is 25 3s. How much, children? 1575. So 67 into 75. So 5 7s are 35, 5 6 are 30 plus 3 33 plus 7 7 are 49, 7 6 are 42 plus 4 42 46, 5 12, then 9 10 5. 5025 is the answer. That is divided by 5025. Then 8 4 is 32, 8 6 is 48 plus 3 51. Okay, this is the value. Then 512 jump. Then this is what? 9. Then 0.8. So what is the answer, children? The force is what? 9.8 newtons. This is the force, nothing but the magnitude is how much, children? The magnitude of the gravitational force is 9.8 newtons. This you can do rough work, children. Here space not there, so I did directly. You will get a force value what? 9.8. Understand, children? Okay, once again let me explain. First, what we have to do, the given data we have to collect it present neatly, children. First, the mass of the two objects given, one is earth and the second one is what? Object. Then radius they has given. Then we have to use the Newton's formula, that is universal law we have to use. By substituting all the given values, we will get force is what? The magnitude of the gravitational force 9.8 newtons. Got it, children? Okay. Now we will move with the another problem. Now we will solve, that is page number 144, question number 12. That is gravitational force on the surface of the moon is only 1/6 as strong as gravitational force on the earth. What is the weight in newtons of a 10 kg object on the moon and also on the earth? Children, what we have learned, that is weight of an object is varies from one place to another. The same concept applies here also. Clearly they has given that mass of an object is what? 10 kg. They are asking that calculate the weight of an object on moon and also calculate the weight of an object on earth, children, isn't it? Example, let us imagine this is what? Moon. So what is the object mass? 10 kg. Then the same object, what will be its mass on earth? Isn't it, children? So what can we write? Mass is what? 10 kg. Mass of an object is 10 kg. First, we need to calculate that is weight on moon. We learned that weight is nothing but a force. That is, force is equals to mass into acceleration. Here weight is equals to what? Mass into acceleration due to gravity. Weight is equals to mass into acceleration due to gravity. But we know that weight in an object on a moon is equals to 1/6th time that of the weight of an object on earth. This we already proved, isn't it, children? So now here the gravitational force value is what, children? 9.8 meter per second square. So now let us take Wm is equals to 1/6th time that of a weight on a earth, no? So we know that m into 1/6th that of, what is that? Gravitational force value. So what is the mass? 10, then 1/6, then what is the z value? 9.8. So which is equals to 3 then 5, isn't it, children? So what is that? 9.8 into 5 divided by 3. So this can be written as 9 5 is a 40, it's a 40, then 45 50 plus 0.3, 3 1 ja, 3 1 ja, then how much remain here? 20, then 3 6, isn't it? S2, then once again 6, isn't it? Or else this point no value, no? Let us take 2 is left. When you take an S, 16.6. So what is the weight of an object on moon, children? 16.6 Newton. What is the unit? Force unit only, the weight unit here. So what is that? 16.6 Newton. Now calculate the same, that is weight on earth. This object weight on earth, that is weight of an object on earth is equals to mass into acceleration due to gravity on earth. 10 into 9.8. What is that? 10 into 98 divided by 10. This 10 get cancelled. So what is left? 98 newtons. So weight of an object on earth is how much, children? 98 newtons, and the same on earth is what? 16.6 newtons. Is it clear, children? Okay, once again I'll repeat. They has given mass of an object is 10 kg. If it measures on a moon, what will be its weight? They asked us to calculate. And in the same way, what is the weight of the same object if we measured on a earth? By applying the same principle or the formula, that is, we already know that weight of any object on a moon will be equal to 1/6th time that of the earth. Now you have to apply the same formula here. Here weight is nothing but a mass into acceleration due to gravity, nothing but a earth, and its value is what? Acceleration due to gravity, 9.8. Now substitute the values, you will get weight of an object in moon 16.6 newtons, then weight of an object on earth 98 newtons. Is it clear, children? Okay, now we will move the next one. Children, now we will solve, that is 13th question. A ball is thrown vertically upwards with a velocity of a 49 meter per second. This is nothing but a initial velocity of the ball with which it moves to a certain height, children. They asked us to calculate the maximum height to which it rises. Maximum height is nothing but a here how much distance it covered we need to calculate, and the total time taken to return to the surface of the earth also we have to find out. For example, children, let us consider this is a stone, isn't it? This stone goes up to here, isn't it? With an initial velocity how much? 49 meter per second. So after reaching at this point, its final velocity will be 0 meter per second. What is this height? We have to calculate Isn't it, children? The first part is what? Height we have to calculate. What we have to do now? Which formula we have to use, children? V square is equals to U square plus 2GS. See, children, here the object is going opposite to the gravitational. Then what will be its G value or A value here? At this time, it will be a negative. Isn't it, children? Because it goes opposite. This downward is what? Acceleration due to gravity. But the object is moving what? Upwards. So, you have to take a negative sign. Meet up a second square. So, what is the V square? 0 square. U is what? 49 whole square plus 2 minus 9.8. Height we are going to calculate now. So, keep same as it is. 0 is equals to, that is 49 into 49 or 49 whole square minus 2, that is 2 into 9.8. Isn't it, children? 2 into 9.8 into S. If this goes to this side means sign will be changed. So, S is equals to 49 into 49 divided by 2 into 9.8. So, this side all 2 into 9.8 will be there. So, if it goes to denominator means that is what? 49 square. It can also be written in this way. So, now this is what? Nearly 49 square means 2401 divided by, that is what? 19.6. Isn't it, children? So, which is equals to, then, yes, yes, 122.5 meter, which can also be written as 2401 into 10 divided by 196. You have to do, children, or else you can do directly here also, no problem. So, what is the height value, children? Nothing but a distance value is 122.5 meter. This is what? A first part. And the second part is what? The total time taken to return to the surface of the earth. See, first from the ground point it goes to up to V. Let us say up to here. Its time will be T. Then again from here to it travels to the ground. So, once again the time is what? Adding. Isn't it, children? Time of a ascent and time of a descent is the total time taken here. So, the total time is what? T is equals to time of ascent plus time of descent. So, first we have to calculate now T value. So, let us use the formula V is equals to U plus AT. Nothing but a GT here. What is the V value? 0. Then 49 plus minus 9.8 into T. If it goes to this side means changes its sign, then 49 divided by 9.8, which is equals to, what is that, children? 490 divided by 98, which is nothing but a 5. Therefore, the time is what? 5 seconds. This is what? Only for one time. Means from ground to particular point. The total time they asked us to calculate, that is T is equals to, if it has taken 5 seconds to go from this point to up to here means it takes the same amount of a time from in order to come from this point to ground point or for the surface of the earth. That is TA plus TD, which is equals to 5 plus 5, nothing but a 10 seconds. So, what is the total time taken, children? The total time taken is what? 10 seconds. Because it takes 5 seconds to go from surface of the earth to particular point, and again from that point to it will come down. No, it will take once again 5 more seconds. So, the total time is what? 10 seconds. Once again, I'll repeat, children. This is a simple problem. They has given what? That is initial velocity given. Then they asked us to calculate the height value, maximum height, how much it has covered. So at that time, we had to use the formula, that is v square is equals to u square plus 2gs. Since it is moving opposite to the direction of the acceleration due to gravity, its sign will get changes. We have to take at this moment negative sign. Then we will get a s value 122.5 meter, and the total time in order to calculate for going up and also for coming down, first we have to calculate just for one time, that is to go up how much time it is taking we have to calculate. Then if we add for the next one means we will get the total time taken, which is equals to 10 seconds. Is it clear, children? Okay, now we will move with the 14th one. Children, the 14th question is that a stone is released from the top of a tower, what is that, of height 19.6 meter. Calculate its final velocity just before touching the ground. Children, from the top of the tower, a stone is going to be released. It means that at its initial velocity will be a 0. We need to calculate its final velocity by using what is that? Tower of a height. Height is nothing but a here s, nothing but a h or distance you can take. For example, imagine, children, this is a tower, isn't it? From here the stone is going to be dropped vertically downward. So here, since it is towards the earth, there is no change in the sign of acceleration due to gravity. So at this point its velocity will be a 0. So they asked us to calculate what is its final velocity. Then if this height is h or s is equals to 19.6 meter, no? Yes, 19.6 meter. Since it is towards the earth, the gravitational attraction will be a positive sign, 9.8 meter per second square you have to take. So let us use the formula, children. Which formula shall we use? Here v we know, u we know, v we are going to calculate, g already given, then s is given. So we need to use the formula. Yes, very good. What is that? V square equals to u square plus 2gs. What is the v square? We are going to calculate its final velocity, no? V is nothing but a final velocity. U is nothing but a here initial velocity. Since it is at the rest, means at that time its velocity will be a 0. So what is that? 0 square plus then 9.8 into 19.6, isn't it, children? Yes, 19.6 meter. So what is that? V square is equals to 0 square means no value here. Then 9.8 into 2, 19.6. Then the distance, nothing but a height, 9.6. So now shall we write this in this way, children? Square root of 19.6 into, or else 19.6 whole square we can write, no, because both are same values. So this square root get cancels. Now what is left? V is equals to 19.6. What is the unit, children? Yes, very good, meter per second. So what is that? The final velocity is 19.6 meter per second. Once again I'll explain, children. Here a stone is going to be dropped from a tower. Since it is at a rest, its initial velocity u will be a 0. They asked us to calculate what is its final velocity. Nothing but a v value we should calculate. And the height of the tower is what? 19.6 meter. The acceleration due to gravity of the earth is what? 9.8 meter per second. Since this object, nothing but a stone, is moving towards the earth, so there is no need of changing its sign. So now apply the formula, v square equals to u square plus 2gs. Then substitute the values. U is nothing but a 0. So then g is what? 9.8. S is what? 19.6. 9.8 into 2 is nothing but a 19.6 only. So this can be written as 19.6 whole square, one and the both the same children. We can write 19.6 into 19.6 also same, or 19.6 whole square is also same. So in order to cancel this one, we'll get a cancellation of this square root and the square, then we'll get a what final velocity as a v is what 19.6 meter per second. So its final velocity is what children? This is the its velocity 19.6 meter per seconds. Okay children, now we will move the 15th one. Children, 15th question. A stone is thrown vertically upward with an initial velocity of 40 meter per second. See children, here a stone is throwing vertically upward direction. It means that it is moving in the upward direction against to the gravitational force. What? With an initial velocity 40 meter per second. So they has given gravitational force value what? 10 meter per second square. Then calculate maximum height reached by the stone and also what is the net displacement and the total distance covered by the stone. See children, let us assume this is a what? Stone. This stone is what? Thrown vertically upward direction. At this moment, its initial velocity, what is that? U is equals to 40 meter per second. Let us say this stone reaches up to here. Then its final velocity will be 0, isn't it children? So, they asked us to calculate what is this height, nothing but a S value, and also the net displacement and a net that is total distance covered we have to calculate by taking the gravitational value, that is 10 meter per second square. Now let us use the formula children. V square is equals to U square plus 2GS, isn't it children? So what is the V value? 0 square, then U is 40 whole square plus 2 into what is the G value? Minus 10, because it is moving opposite to the direction of the gravity children. So the sign will changes. So what is the S value? Yes, S only we are going to calculate. So now this can be written as, that is 0 is equals to 40 whole square minus 20. Yes, if this goes to this side means what it becomes children? Plus 20S is equals to 40 whole square. Nothing but S is equals to 40 into 40 divided by 20. 0, 0 get cancels. 2 1 ja, 2 2 ja. So what is the distance or the maximum height children? 40 into 2. Nothing but 80 children. What is that? 80 meters. So what is that? From the height of which it has travelled is what children? 80 meters it has travelled with an initial velocity 40 meter per second. This is one part. Now we have to calculate what? The net displacement. Net displacement we have to calculate. See children, let us assume that this is a starting point. From this point it will goes up to here. Let us say up to here. Then again from here to it will come back to this point. Isn't it children? So at this case, if the initial point and the final point will get a same side or same point, means if initial position and the final position coincides, it means that if it is at the same point, because it is moving up and again coming back to the surface of the earth, no, then what happens? Both the points, initial point and the final points will be at the same point. It means that both are coinciding. So at that case, the displacement will be 0. What is that? The net displacement is what? 0. The next, what is that? The total distance. Total distance. We already know that What is the height it has covered, children? 80 meter. So again, after reaching this point, at particular point, it comes back, no? If this is of 80 meter means ultimately the return travel distance also will be 80 only. So the total distance is what? 80 meters plus 80 meters, which is nothing but a 160 meter. So it has covered 160 meter. So the total distance is 160 meter and the net displacement is 0 because both the points, initial point and the final point, are coinciding. Hence the net displacement is 0 and the height is what? 80 meter. Once again I'll repeat, children. They asked us that if an object, nothing but a stone, if it moves vertically upward direction with a velocity 40 meter per second, calculate its height. The given acceleration due to gravity is what? 10 meter per second square. Since it is moving against, means opposite to the acceleration due to gravity, we need to change the sign. Apply the formula v square is equals to u square plus 2gs. Now substitute the values. V is nothing but a final velocity, isn't it, children? If it moves up to here means here it halts, means its velocity decreases, no? It goes to 0. Then what happened? We will get a S is what? 80 meters. And also what? The net displacement for going up and also for coming down, both the points are same. Hence the displacement is 0 and the distance, for one time if it is covering 80 meter means, and also to return from the particular point to the surface of the earth, it will cover the same distance. The total distance is we need to add for going up and also for returning down. Then 80 plus 80, you will get a 160 meter. Is it clear, children? Okay. Now we will move the 16th one. Children, the 16th question is of that. Calculate the force of gravitation between the earth and the sun. Given that the mass of the earth is what? 6 into 10 to the power of 24 kg and of the sun is what? 2 into 10 to the power of 30 kg. The average distance between the two is what? 1.5 into 10 to the power of 11 meter. It means that here the mass of earth and the mass of the sun has given as 6 into 10 to the power of 24 kg and 2 into 10 to the power of 30 kg. Mass of two different objects they has given and the average distance, nothing but the radius value they has given. They asked us to calculate the force. So once again we will use the same formula, children. Universal law formula, F is equals to G into M1 into M2 divided by R square, isn't it? That is, let us consider this is what? Sun. So its mass is how much? The sun's mass is 2 into 10 to the power of 30 kg and that of earth, its mass is 6 into 10 to the power of 24 kg and the average distance between these two, isn't it, children? So what is that? Radius is 1.5 into 10 to the power of 11 meter and F we has to calculate, and the gravitational constant value we already know, 6.7 into 10 to the power of minus 11 Newton meter square per kg square, isn't it, children? This is the constant value. Now use the formula. F is equals to G into mass of sun into mass of earth divided by R square. This is what? Formula. Now substitute the values, children. F is equals to, what is this? Now substitute the values. 6.7 into 10 to the power of minus 11 into, what is the mass of the earth? 2 into 10 to the power of 30 and that of earth 6 into 10 to the power of 24 whole divided by, what is the radius value, children? 1.5 into 10 to the power of 11 whole square, isn't it, children? Now let us take all exponents one side, children. That is, F is equals to 6.7 7 into 2 6 12 into 10 to the power of, what is that, 30 plus 24, 50, that is 54, 54 minus 11, isn't it children? 54 minus 11 divided by 1.5 into 1.5 into, what is that, 10 to the power of 11 into 2, nothing but 10 to the power of 22. So F is equals to 6.7 into 12 into 10 to the power of, what is that, 43, and this goes to numerator means sign changes, what is that, 43 minus 22 whole divided by 1.5 into 1.5. So F is equals to, that is 67. 6.7 can be written as 67 divided by 10, isn't it children? So 12, then what is this, 1 is 2 and 1, then 15 into 10, and which is what, 10 to the power of 2, isn't it children? Nothing but 100, no, this can be written as, so F is equals to, now 3 4s are 3 5s are, isn't it children? Next, you can do directly, no problem. This is what, 4, no, yes, 67 into 4, then 10, 1 0 1 0 get cancels, so 10 to the power of 1 is left, so 21 plus 1, 10 to the power of 22, then 15 5s are, what is that, 75, isn't it children? 67 into 4, what is the value, 67 into 4, 4 7s are 28, 4 6 are 24, 25 26, so F is equals to 268 divided by 75 into 10 to the power of 21, so 75 ones are, then 3s are, then 5s are, then 6, or approximately you can take 3.57, so F is equals to 3.56 or 57, approximately 3.57 will get into 10 to the power of 22 newtons. This is the force acting on these two objects. Is it clear children? Once again explain, mass of sun they has given, and also mass of earth they has given, and the average distance, nothing but the radius value is what, 1.5 into 10 to the power of 11 meter they has given. They asked us to calculate its force. Now we have to use the formula, universal law, that is F is equals to G into m1 into m2 divided by r square. Then by substituting all the values, you will get the force value 3.57 into 10 to the power of 22 newtons. Is it clear children? Okay, next we will move with the 17th problem. Children, now we will solve the 17th question. A stone is allowed to fall from the top of a tower 100 meter high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 24 meter per second. Calculate when and where the two stones will meet. Children, let us take, this is what, a ground, okay. The stone is moving from here to up to here. So this is the what, height, how much? Nothing but the distance is 100 meter. And the second what they ask, at the same time another stone is projected vertically upwards. See, this is a tower, okay. Let us consider this as a tower, and its height is what, 100 meter. And one more stone is projecting upwards, means it is moving vertically upwards. Let us say both the stones, this stone and this stone is meeting at this point. We will call this as a point P. Hey! Kattegada. Children, now we will solve a stone is 17th question. Children, now we will solve 17th question, that is a stone is allowed to fall from the top of a tower 100-meter high. Let us say this is a tower height. How much, children? 100 meter. This height is what? Height of a tower is 100 meter. And at the same time, a stone is falling down in this way, children, and at the same time another stone also projected upwards vertically with the initial velocity u is equals to 25 meter per second. Calculate when and where the stones will meet. See, children, this is a little bit confusion question, but understand it clearly. First, a tower is there and which is of a height 100 meter. Isn't it, children? From top of this tower, a stone is falling down. If it is towards the gravity, means there is no change in the sun. So, when it is at the top of the tower, its initial velocity will be a 0. This is what? First part. And this height of the tower is 100 meter. And both the stones are meeting. Let us say this is a point P. Let P is the point where two stones will meet. Okay. So, children, if the total is 100 means we don't know this how much part. Isn't it, children? Let us say let x is the distance of the stone which is vertically projected upwards. Isn't it, children? So, what is this now? Better I'll erase this. Now, this will becomes x. X is the distance. And this distance is what? The entire height is what? 100. So, we don't know the unknown value. Let us say it as a x. So, from this point to up, let us take the height is what? 100 minus x. So, now first part what we will do, that is if the stone falls towards the ground, then u is equals to 0 meter per second. Then gravitational force is 9.8. There is no change in the sign, children, because it is coming down. Meter per second square. So, let us say that is S is what here? S is equals to 100 minus x. So, let us use the formula S is equals to ut plus of gt square. Okay. Now, substitute the values, children. That is 100 minus x is equals to u 0 into t. Yes. What is the time, children? Timing we has to calculate. So, let us take it as the same t only, plus half 9.8 t square. Isn't it, children? So, now this will becomes 2 1s 2, 4 and 9, 4.9 t square. So, this can be written as now, which is equals to 100 minus x is equals to, because children 0 into t is nothing but 0 only, then 4.9 t square, 4.9 t square. This is what? Equation number 1. Let us consider this is what? Equation number 1. Now, if the stone is projected vertically upwards, that is, if the stone is vertically projected vertically upwards with the velocity 25 meter per second, then G is, now see children, this stone is moving opposite direction to that of a gravity. Now let us change this value now, minus 9.8 meter per second square, and the S is what? This height you have to take now. The second stone now, it is covering up to this much, means X. X is the height of the stone which is covered. Okay. Now, once again is the formula, S is equals to UT plus half GT square, which can be written as S is nothing but a X, UT means 25 into T plus half into, what is that? Minus 9.8 T square. Isn't it children? So, once again do the same, 4.9. So, which is equals to how much children? 25 T minus, plus into minus, minus 4.9 T square. So, what is that? X is equals to 25 T minus 4.9 T square is the second equation. Now, we have to find, that is, add equation 1 and 2. So, what is the equation number 1? 100 minus x is equals to 4.9 t square, that is 100 minus x plus, let us take all left hand side once. Then what is left? That is on right hand side, 4.9 t square plus 25 t minus 4.9 t square. Isn't it children? So now this x get cancelled. Then this 4.9 t square and this 4.9 t square get cancelled. What is left? 100 is equals to 25 t. So what is the t value? T is nothing but a, yes, 100 divided by 25. Isn't it children? 5, then 2, 5 and the 5 4. So what is that? The timing is what? 4 seconds. Got it children? Now, we had to substitute this t value in equation number 1. That is, substitute t value in equation 1. What is that? 100 minus x is equals to 4.9 t square. So, what is the t value children here? 4. That is 100 minus x is equals to 4.9 into 4 into 4. This is what? 100 minus x is equals to 4.9 into 16. 4 into 4, 16, no? Yes. Now, 4.9 into 16, which is nothing but a 78.4. So, 100 minus x is equals to 78.4. Then x is equals to 100 minus 78.4, or x is equals to, what is that? 21.6 meter. So, what is the x value children? 21.6 meter nearly we will get. So, once again I will explain children. Here from the tower and stone is falling in the downward direction. So, at that time its initial velocity will be a 0. Since it is moving towards the gravitational force, so there is no change in its sign. Let us say that is another stone. In the same time, another stone is also going to be projected vertically upwards. Since it is in the opposite direction, you have to change the acceleration value. Let us consider both the stones are meeting at a point P. At this point, isn't it, children? So, if the entire tower height is what? 100 means, at this point, from ground to point P, the distance will be x. Let us consider or assume its distance, because we don't know, no? Let us take it is what? X. Then next, what is the distance then from this point P to tower? That is 100 minus x will be a distance. So by assuming all these things, then substituting in the value, so that is formula s is equals to ut plus half gt square, we will get what? Timing as a 4 seconds. Then the distance is what? 21.6 meter. Is it clear, children? Okay, next we will move with the 18th one. Children, now we will solve 18th question, that is a ball thrown up vertically returns to the thrower after 6 seconds. Find the velocity with which it was thrown up and also maximum height it reaches and the position after 4 seconds. See children, let us consider the person is at here. He is throwing a ball from here to here. It travels at this height or at this level. So at this moment, what is its velocity we should calculate. And when it goes to certain points, then its final velocity will be 0 here. The maximum height, nothing but a s we have to calculate. See, this person is throwing ball from here to here and again it comes back to the thrower. It means that for this, it is taking 6 seconds. Means for going 3 seconds and also the ball to returning to the person 3 seconds. So, the timing will be, the total time is nothing but a time of ascent plus time of descent. So, the time is what? 3 plus 3. So, what is that? The total time will be 6 seconds. So, to go up, how much time it has taken, children, now? That is, the time is what? 6 seconds. So, the time of ascent to go up 3 seconds is the time value. First, let us find, yes, here only we will do, V is equals to U plus GT. See children, he is throwing vertically upwards, means it is moving, the object, the ball is moving against to the opposite to the gravitational force. So, the G will becomes minus 9.8 meter per second square. So, what is the V value? 0, and U we have to calculate plus minus of 9.8 into 3. So, 0 is equals to U plus into minus 9.8 into 3, 29.4. 3 into 24, then 3 into 27, 28, 29. Okay, 29.4. So, what is the U value, children? 29.4 meter per second. So, with this velocity, the object, that is the ball, is moving up. The next part. What is the next part, children? We have to calculate the maximum height it reaches. So, S we have to calculate. So, let us use the formula V square equals to U square plus 2AS, isn't it? GS here. Now, what is the V value? 0 square. What is the U value? 29.4 whole square plus 2 into minus 9.8 into S. So, that is 0 is equals to 29.4 whole square is nothing but a 864.36, you may get, minus 2 into 9.8 means 19.6 S. So, if goes to left hand side means sign will get changes. So, 19.6 is equals to, sorry, S into S is equals to 864.36. Therefore, S is what? 864.36 whole divided by 19.6. So, when you do cancellation of this, you may get 44.1 meter around. So what is that? 44.1 meter is the height it has covered. Children, now we'll solve the third part, that is its position after 4 seconds. That is after 4 seconds. So children, for 3 seconds it is covering 44.1 meter. Then 4 second means 3 second plus 1 second you can write now. That is nothing but a 4 second meaning. So now S is equals to ut plus half gt square. So when the time t is 1 second, the position nothing but a S we have to calculate. So S is equals to, what is the u value children? That is 0 into 1, because its initial velocity at that moment will be 0 plus half, what is the z value? 9.8 into 1 square. So what is that? S is equals to 0 plus 2 1s are 2 2s are, then 2 4s are and 9s are. What is that? 4.9 into 1. So what is its position children? 4.9 meter. Is it clear children?